And now we should see a red button in your screen, right? Are we live?
I see now it will be recorded, and after the things is finished, I get the...
Yeah, you can also stop the recording at any time. Now I also started, so both of us will have recordings. We take the better one. Okay, everyone, I'm just gonna get too eager to start. So I would say 3 minutes are halfway through the 5 minutes mark. Let's get it going. And if people are still joining, that is fine. I will also turn off the computer sound so that you don't have the bing bing every time somebody joins. Hello, everyone. Welcome to the virtual Berlin Droid January 2021. This is the first meeting in 2021, and it will hopefully not be the last one in 2021. Like we did in 2020, if you have any questions regarding the whole setup, the talks we have, please feel free to go to this link up here, go to the QA section and add your questions there. Afterwards, we will talk through the questions there, but also if you feel like speaking up after the talk is important there, we could also do this one if you feel like you want to voice your questions live, and then we have a bit of an interaction there. What else do we have planned for today? We have this weird face talking a bit about 2020. That's going to be me, so you will be staying with me just for a bit longer. But to mix up the speakers, we will also have Daniele talking about D-KMP architecture. With that said, let's directly dive into more Android questions. Like, not only do I want to show off another way of creating QR codes, but also if you feel like you want to be talking in front of our audience, please use talk.berlindroid.de or scan this beautiful QR code that actually works, hopefully TM. Fill out the form there, and you can be part of this awesome community by giving a talk centered around Android, whatever this means. And that said, we also have monthly meetings, which is like you are part of one right now. Congratulations. We will keep having them hopefully also in February, and our next one will be the 24th of February, announced through meetup.com and Twitter. So please take a look at those channels, and you will get informed how to join our next meeting. Now, let's go to the TMI part of the talk, too much information, right? We have this tradition of just like seeing what did we actually do last year, and I just want to keep adding to this one. So again, same slides. Please take this QR code. That looks a bit boring, I know, but still it represents the way you can ask questions. We already got a question, which is your question. Thank you for that one. Let's see if we can add more questions to this one. But like what happened actually last year with the Android community? Here you see a beautiful color code in probably way too small font that goes through our Meetup group and just lists all of the meetups we have, sorts them by name, and counts them. We had 33 Android co-learning sessions. So this was our weekly meetup where we met in person. Yeah, I know, strange thing, but we get to this one. And we're solving problems we had with our code bases individually, privately. What is your private project? Come to it, come to this event and talk about it. We also had 6 Android meetups. This is like, actually, you can see that the math doesn't add up. It would have been 9 meetups, right? Because we had the Berlin Droid in-person meetings, we had online meetings, we had the October 2020 meeting, and we had the Android 11 developer meetup, which was great, where we had like actually something like the big Google I/O local event, where we had the Android developers actually speaking about what is new in Android 11. But also, let's go through how did those shape up throughout the month, right? So this is a list of, okay, we had in January 6 meetups, in February we had 2, March, in February we had 5, in March we had 5, we had 6 in April, 5, 5, 5, 4, 1. So between August and what's the word, October, we missed 1 meetup, and also the overall amount of meetups fell a bit flat. Why is this? A surprise to no one. Hopefully there was a crisis going on, that it's currently the pandemic called Corona. So we stopped having in-person meetings. So like we started meeting in this regard, but also we faced some issues like just getting ourselves technically set up and also mentally set up to organize more things together. So that's why we reduced a bit of the amount, but it's okay. We can see how 2021 goes. Another interesting thing is like, yeah, we keep it usually encouraging people to take pictures during the meetups. For some reason, there were only screenshots of Hassan and other people using the virtual reality or virtual meetups to the best of their skill set. Thanks, by the way, for that one. But also, interestingly enough, there was another nice part of the October meeting, which is we decided to use an online system where you can admit people randomly. And we also decided, and that is me in this case, to post this link publicly on Twitter. And as we know, Twitter is a great place to post virtual meetup links because all the people can join. And all the people joined, also people joined who said like, hey, yeah, I don't want to actually be participating in the group. I just want to show you my videos and have your loud and obnoxious voice noise thing heard too through your headphones. So we learned a lot last year is what I wanted to say. In this case, we also learned that we shouldn't post our Twitter links, our meetup links on Twitter and have a bit more restriction in like who can actually join. That said, since we are all now joined and happy together, what's 2021 for us? We, obviously, I have to say, we asked the question also to the community, what is the one word or what's the sentence, what is the tag you are assigning to your Android community? Essentially trying to find out like, what's your connection, what is the thing you want out of your community in 2021? It resulted in this beautiful Android symbol. So I hope you can see it. The most people voted for or said that this community, what they're connecting to is like equally Android and equal parts people. So somehow it's both together. But also a lot of things were around technology topics about learning, sharing, making, support, but also things that are more people related, like hiring, nothing, I'm not sure, GitHub, like all of those things. So like this kind of shapes an idea on what we as organizers might like to think about what we could be doing next. How do we get people together in technology topics, or how can we improve their chance of hiring? How do we do more Kotlin and whatnot? So thanks again for all of the contributions. I'm looking forward for also your feedback on the Slido link and also on our Twitter channel and all of the possible channels we have. Please feel free to reach out to us if you feel like you can contribute into the direction of this group, because we only live from us being a community together. And that said, I have to say thank you. And we now all know what this means. Daniele, you can have your talk now, and I'll give over the control to you.
Okay, let's see. Oh, can you see the screen now? Yeah, but not full screen. Okay. Good. Yeah, so welcome everyone. Thank you for having me here at this GDG Berlin meetup. So we'll talk today about this D-KMP architecture, where D stands for Declarative UIs and KMP stands for Kotlin Multiplatform. And then we add this extra sauce, which is the MVI pattern, which is what makes the two things work the best. But before we start, we're going to have a very quick poll, which you should find on the chat, and I will post it again if you cannot find it. Okay, yeah, yeah. So let's just give an answer, sorry, of which kind of technology you used in an app, and then we are going to show the live results, so we get an idea of the audience, which is the experience that they have in app development, which is going to be interesting for everyone. So hopefully everyone voted already, I hope. Let's go to see the results. Ah, interesting. Can you see the results? Can you see? Right. Yeah, so of course everyone has got experience with Android. Then we have a few people with experience with iOS, Flutter, Jetpack Compose, even MVI partner, interesting. And some with React, yeah, good. Interesting, very interesting results. So 12 people, so we are 30 people. So we are 38 people, so there'll be more people maybe should vote so we get more responses. You find the link in the chat if you want. Yeah, okay. So I think we get an idea. So everyone knows Android and some knows iOS and some has experience with Jetpack Compose and with MVI pattern. That's good. And some with Flutter too and with SwiftUI. Interesting. Okay, so let's go on with the talk. Okay, so, you know, in the past, I mean, app development has always been about developing for the single platform specific. So if a company wants to do 3 apps it wants to do an app for Android, iOS, and web, typically like 90% of companies or even more, they would develop platform single apps, 3 whole apps with no shared code. But this also means that there will be 3 times the bugs. And luckily in the future, this is not going to be the same. So we're going to have more opportunity. And today we're going to talk about the D-KMP architecture, which is an architecture based on Kotlin Multiplatform, where we can share, okay, now better, where we can share up to 85% of business logic. And then we have platform specific UI. And the UI layer, it would be the only platform specific code. So let's go more in details talking about this architecture. So as you can see also from this, from the diagram, we have a business logic and the UI which are fully decoupled. And you only share the business logic, which is, by the way, the biggest part of the code, which is 85%. And very interesting, I mean, we don't share the UI, and for this reason of not sharing the UI, we gain interesting flexibility of being able to target any kind of device, which is something that you would not be able to achieve with a framework like Flutter and React Native, because in Flutter and React Native, you lock yourself into their own UI framework. If you use KMP, you don't make any choice. And so this opens a possibility to use any UI toolkit you want. For example, now this new Harmony OS is coming up from Huawei. We don't know much about this Harmony OS, but we can expect they would have their own UI toolkits. So if you use Kotlin Multiplatform, you just share the 85% of the business logic, and you would be able just to add a very thin layer for the UI toolkit by keeping everything like it is. So this is a very fundamental aspect of KMP, because which differentiates KMP from Flutter and React Native, as I said already. So let's see which are the 3 pillars of the D-KMP architecture. So one is the declarative UIs, and it's something which is really fresh topic somehow in mobile development, because very recently both Android and iOS, they presented their own declarative UI toolkit. So in Android we have Jetpack Compose, and in iOS we have SwiftUI, and these 2 UI toolkits, they are going to fully, we think, replace the classic UI toolkit. And the second pillar of the D-KMP architecture is Kotlin Multiplatform, and we'll talk more in detail later, but is a multi-platform technology that finally makes sense and it works. And then the third pillar is the MVI pattern, which is based on unidirectional data flow and single source of truth for the app state. And typically, MVI pattern used to be implemented through RxJava, but we are going to show in this D-KMP architecture that we are going to implement the MVI pattern fully in Kotlin, and is going to work multi-platform, wherever Kotlin works, which is basically everywhere. Before we go more into details, I want to thank the people who already did quite a lot of research in MVI, Kotlin Multiplatform, and Declarative UIs. And in this presentation, what I'm doing is kind of connecting the dots and to provide a solution based on something which has already been researched quite a lot in the last years, let's say, or months. Okay, so let's present here a very simplified diagram where we talk about what the app development was in the past and what is going to be in the future. So in the past, app development was based on imperative UIs. And with the word imperative UI, we mean the classic, the traditional UI toolkits. So the view-based toolkit in Android and the interface builder in iOS. And one interesting thing which is common to both imperative UI toolkits is that they are all based on the components are all based defined by IDs, okay? And in order to connect data coming from the view model to the layout, you always need to reference directly the ID, and you always need a middle layer to couple the UI layout and view model. So this is what we mean, you know, we're very familiar with find view by ID, or now we have view binding, but we still have a coupling layer that connects the view model, the data coming from the view model, to the UI layout of the imperative UI. So in the future, with declarative UIs, components don't even have an ID defined, and we don't have at all this kind of middle layer. So we are able to apply data from the view model directly on the UI layout. And we are going to see simple examples in the next slides. So in the past, as we said before, we used not to share anything apart from, of course, web services, which is on the server side. But on the client side, we used not to share much because it was expensive. It was not, I mean, not expensive, but we didn't have the real technology. Okay, recently with Flutter, things changed, but now with Kotlin Multiplatform, we can really assume that the standard way, and okay, this is a very strong statement because we are still in the early of 2021, but at the end of this year of 2021, I assume this is going to be the standard to create a shared view model and business logic on the client. Okay, so let's go more into details and let's just summarize what we said actually. So in the past, we had UI layout and view model, which require a coupling middle layer. In the future, with the declarative UIs, we are not going to have this middle layer at all. In the past, we tend not to share any code in the client. In the future, we are going to share up to 85% of code. So in the past, we had patterns like MVCs, MVP, or MVVM. In the future, we are really going to see a pattern like MVI with a single source of truth for the app state, which is going to really become very relevant because it fits perfectly with the declarative UIs concept of stateless. And we're going to see more in the next slide about that too. And then another interesting that we can expect is going to happen in the future, because in the past, we tend not to share any code in the client. So companies tend to develop architecture which were thin client, because putting logic on the client, it was very expensive because it had to be replicated across all different platforms. With a multi-platform approach, we can expect that we have a client which is much richer, because it is inexpensive to create, to have logic on the client. And having logic in the client, it means that the user experience can really be much better, because we can have very interesting caching mechanism or any kind of logic which has to do with data, which can be really advanced and improve user experience a lot. So I would expect this to happen. You know, we are going to see much better app in the future with this multi-platform approach. Okay. Other things is very important to highlight. So the D-KMP architecture we're going to present today is aimed at greenfield projects. So this D-KMP architecture is not about gradually introducing declarative UIs and KMP to existing project, but is about presenting a clean, solid, and we believe future-proof architecture, which is making no compromises with the past. And another important point to highlight is that D-KMP is not a library, because some people can get mistaken, but it's actually an architecture. And as an architecture, is using the existing official frameworks. Okay, so let's talk about the first pillar, which we introduced, being the declarative UIs. So with a little bit of a timeline, so declarative UIs became popular on the web thanks to React.js, which is a framework created by Facebook in 2011, which was outsourced in 2013. So in terms of mobile, declarative UIs started to be introduced by React Native, which is the mobile version of React, but then even more importantly by Flutter. And I believe Flutter is what really showed how a declarative UI toolkit can be very effective for mobile apps, much more effective than the traditional UI toolkits that we still have in Android and not so much in iOS. Well, yeah. So in May 2019, in Google I/O, Google finally announced a declarative UI toolkit for Android, which is JPEG Compose. And interestingly to say that when it was introduced in May 2019, it was introduced as experimental, while Apple in June 2019 introduced SwiftUI as the declarative UI toolkit for iOS, but it was not introduced as experimental, but as version 1.0. So, you know, like it was meant to be ready for production, and maybe it was not that ready, but luckily it was improved in the later version 1 year later. Let's see some simply some characteristic about the declarative UI. So they just describe how the UI looks like for the different app states, but they are stateless. So they don't manage the app state directly. And the UI layer can be neatly decoupled from the view model. And let's compare the imperative UI toolkit with the declarative UI toolkit. So as we said before in 2-3 slides ago, on imperative UI, we have always a middle layer, an extra layer that is needed to apply data. And we know this with a find view by ID on Android. Now Android is trying to make this easier with view binding, but still in view binding, you still have a layer of code that is needed to apply data on the layout. And similarly, we have in the traditional UI kit in iOS a similar concept with the layout, which is drawn through interface builder, but you still need the code to couple the IDs you define in interface builder with the code. And this is something very different in declarative UIs, because we don't have this middle layer, and actually we don't have IDs either on components. So we can apply directly data which is coming from a view model directly on the UI. And this is really removing a big amount of boilerplate code, and it's making development much more fun as well, to be honest. And this is the future, and it looks like OS is moving into this direction, and finally mobile too. So just summarize on Android, Jetpack Compose. So it was introduced in May 2019. It was announced in Google I/O, and it reached alpha in August last year, and is going to reach beta in the second quarter of this year, and stable by the end of this year. Interestingly, is going to support all Android versions, all devices that have Android version 5 or later. So it means that any update to the Jetpack Compose library is going to be compatible with all devices. I mean, it's going to be backward compatible. So because Jetpack Compose is a library which is similar to, app support, app compat library. So it's just a library that you define on the Gradle file, and if you want to get the new version, you just update the version and then you apply in your app, which is something different to iOS, because on iOS, SwiftUI is linked to the framework, to iOS. So this means that all the updates on SwiftUI are not going to be backward compatible. You always need to deliberately target the latest version of iOS if you want to use the latest version of SwiftUI. And let's see for the web, Declarative UI for the web. So Kotlin provides very convenient wrappers for React. So if you want to write a React app, you can do it actually without JavaScript using Kotlin, which is kind of interesting, but I think there's something which is going to be even more interesting very soon, which is Compose for web, which is basically the Jetpack Compose version for the web, but it's still at a very early stage because development started just a couple of months ago and is led by JetBrains. So we can expect that APIs of Compose for web is going to be very similar to the Jetpack Compose APIs, probably not identical, but still very, very similar. So you understand which kind of advantage it would be if we could reuse not just this business logic 85%, but even maybe the 10% of the 15% of Jetpack Compose in Android. So it's going to be awesome. It's going to be flawless to write web apps using Kotlin and Compose. And then in the future, we can expect that Compose would be compiled to WebAssembly as well, which we all expect that is going to be the future for the web. So in summary, we can expect in the very near future that there will be only two families of declarative UIs. One would be the Compose family, which is developed by Google and JetBrains. And currently you can already use in Android, in desktop, macOS, Windows, Linux, and web, which is now just started the development. And hopefully we are going to be able to use Compose also for Wear OS or Google TV. While SwiftUI already now you can use for seamlessly for iOS, macOS, watchOS, and tvOS. When I say seamlessly, basically you define the components once, and then it's the platform that is rendering this component according to the device and the operating in the the device that it is on. Okay, so let's show a very simple example of how Jetpack Compose and SwiftUI look like. So this is we are just showing here in Jetpack Compose a row, which is a equivalent of an horizontal linear layout in the classic Android view-based system. And as you can see, and in SwiftUI, we are showing an H stack, which is basically the same thing, is still like a equivalent of horizontal linear layout. As you can see, the concept is really much the same. What you see, this row object with all these fields, this is data, as I was announced, saying previously in the previous slides, that you are able to apply data directly, and you can have a visual, you can see visually here that we don't have any IDs on these components. So we are able to apply the data as it is directly on a component. So here we have a linear layout with 3 text elements, and one is the day, one is cases, one is different, 3 different fields, and we just apply like that, very, very simply. And the same thing in Swift UI. And so the concept of both is really, really similar, just the syntax, which is different. JPEG Compose is actually written in Kotlin, while Swift UI in Swift. Okay, so let's now talk about the second pillar of our architecture, which is Kotlin Multiplatform. Let's give some history. So Kotlin Multiplatform was introduced as experimental in November 2017 with Kotlin 1.2. And at that time, just added support for JavaScript, for the web. In Kotlin 1.2.20, in February 2018, there was added support for iOS with Kotlin native. And last August, it reached alpha with Kotlin 1.4, and we can expect in the next version of Kotlin, which is now going to be every 6 months. There's going to be now every 6 months a new version of Kotlin. We might expect it might reach beta, maybe this time, maybe next time. But what is important to state here is that Kotlin Multiplatform is already it's very stable already. There is no blocker that is preventing you to develop something. Of course, in beta or in the stable version, they're gonna improve things like debugging or memory management, but already there are no blockers that stop you for starting, experimenting, and even writing production app very soon with the Kotlin Multiplatform. If we compare the timeline of Kotlin Multiplatform with the Declarative UI timeline, we can see that it's pretty much, okay. Oh, cannot see what happened. Hello? Something happened? Okay. All right, yeah, sorry. Okay. Can you hear me?
Yes, we can.
Yes,
Yeah, sorry. Don't know what happened. Okay, so if you compare the timeline of Kotlin Multiplatform with the Declarative UI, we can see that it's pretty much in line with JPEG Compose, and so that's, we can expect by the end of the year to be able to confidently develop production app with both Kotlin Multiplatform and JPEG Compose and Swift UI, which actually this year is gonna become 3.0. So as I was saying earlier, the first version of Swift UI wasn't really that stable, I would say, but version 2.0, which came out last June, it was introduced in WWDC last June, is much more stable, and maybe we're gonna see interesting improvements even in the next version. So Kotlin Multiplatform currently is able to target to compile to 3 different targets, which one is JVM, which is, we know very well, for Android, and also for the server side, it's possible. And Kotlin native, which we target for iOS, macOS, and the other desktop platform, and JavaScript that we target for the web. Then next year, we are expecting there's going to be a 4th compilation target, which is going to be WebAssembly, which used to be native, but included in the native. But now they're going to really restructure the whole compilation, because it's going to be it's going to include a garbage collector. So it's going to be a separate for compilation target for WebAssembly. So when we write business logic with Kotlin Multiplatform, then we compile on the different platform in different kind of files. So in Android, we compile simply to a jar file. In iOS, to an Objective-C, not really file, because Objective-C framework is like a directory more than a file. But it's like, so this is like the formats in the different platform of a business logic developed with Kotlin. So in Android, the jar file, in iOS, an Objective-C framework, and in web is a JS file, JS library. So let's now compare D-KMP with Flutter and React Native. So as we already said, the user interface in D-KMP is developed using the UI native toolkit. So Jetpack Compose for Android and Swift UI for iOS. In Flutter, they have their own set of widgets, and React Native as well. So the business logic in D-KMP is written in Kotlin. In Flutter, they use the Dart language, and in React Native, JavaScript. And let's see how these apps run. So in D-KMP, an app run with, as we said earlier, with the jar library for Android and Objective-C framework for iOS. And we are using the native UI for both Android and iOS. This is not happening in Flutter, because in Flutter, we are not using native UIs. We are using, Flutter is using their own, a specific, a Skia graphic engine, which is, is their own. In both platform, in both iOS and Android, you would see the UI that look the same. And technically, an app, a Flutter app in Android is an NDK app, and in iOS is an LLVM app. And in React Native, we use native UI for Android and iOS, but the drawback is that the code that is actually running in React Native apps is a JavaScript code, and which is able to communicate to the framework through a C++ bridge. In terms of efficiency, in terms of bundle size, there is no doubt that D-KMP is the best out of these three frameworks. But also in terms of nativeness, in terms of performance, is definitely the best one. Okay, so in terms of, we see often, I think people get confused because they see several acronyms that all mean Kotlin Multiplatform. So recently there was this new acronym KMM, which was introduced in August by JetBrains. With KMM, we just mean mobile operating system, so just Android and iOS. And recently, JetBrains even released an Android Studio plugin from KMM, which allows a developer to run iOS app inside of Android Studio. And this is a really, really powerful plugin that basically you almost don't need Xcode anymore if you want to run an iOS app with a Kotlin Multiplatform business logic. And while KMP means Kotlin Multiplatform and is referred also to desktop and web. An interesting thing that is happening in Kotlin is the new, so in Kotlin Web, in Kotlin JS, we are going to have a new, in the second quarter of this year, there's going to be the new JavaScript IR backend, IR backend. So this is a very important milestone for Kotlin Multiplatform on the web, because it's addressing particularly the bundle side for web. And this is going to make web app written in Kotlin much, much more effective. So we are really looking for this improvement, which is going to, for the JR backend to become stable, because then, we can really start talking more in details about these web apps written in Kotlin. At the moment, they're not really, the best, I would say. So the suggested time for shipping D-KMP apps. So I would say for Android and iOS, I would just wait the second half of 2021 to ship apps in production. So I would wait for the beta version of Jetpack Compose. While for the web, I would definitely wait for the Kotlin IR backend, and hopefully for Compose for web, which hopefully is gonna come soon. But definitely you can already start designing and developing apps using KMP, because this 85% of business logic is not really affected by anything. You can already write that, and then when the new Compose for web is coming up, you can just add the UI toolkit of web. So yeah, there's no blocker. So there's nothing stopping anyone to start using Kotlin Multiplatform. Okay, let's now talk about the third pillar, which is the MVI pattern. So the MVI pattern is usually seen as an evolution of the MVVM pattern, which is the pattern which is most used nowadays in Android development. So it's based on the unidirectional data flow and on the single source of truth for the state, for the app state. So which means that the state of an app can only be modified, is only managed by the model. So it cannot be modified by any other element. For example, if the view wants to modify the state, it cannot modify directly. It has to go through the flow, through an intent, and through an intent then generating an action which is modifying the state. So as we say, so MVI pattern is based on the single source of truth for the UI layer, which is the app state. You can see also in the diagram here. The app state consists of immutable data and can only be modified by the view model, which you can also see here in the diagram. The view model, which in our D-KMP architecture is made of events and state reducers. And is following a unidirectional data flow. So what happens is that in the UI layer, a user trigger an event or intent, as you want to call it. Then there's going to be the view model, which changes the app state through the state reducers, and then the view, which is applying the new app state. So it's all unidirectional. So in our D-KMP architecture, we said we are not using RX Java, we are using Stateflow, and this allows us to implement an MVI pattern which is multi-platform, because Stateflow, it's part of Kotlin. It was released in May 2020 as part of the Kotlin coroutine 1.3.6, and yeah, it's enabling a multi-platform MVI. Stateflow, you see also in the diagram, is written there. So it's what allows the app state to propagate from the view model to the UI layer. And talking about the app state, so the way that we organize the app state in the D-KMP architecture is to, so we expect an app to be made of different screens, clearly. So an app state would include all the information of all the screens. So, and we organize this data needed by the screen by property, by assigning a property to the state data of each screen. And we do this lazily using the by lazy keyword in Kotlin. In this way, this data is going to be instantiated only if it's accessed. So typically, if we visit that screen where this data is needed. So if we have 20 screens in our app and in our session, we only use 3 screens, for example, we would only instantiate 3 state objects for the 3 screens. So in terms of the view model, we can see that the view model is just a Kotlin class, which is a shared Kotlin class, which is a KMP class. So it's yeah. And it's, we can see that the state flow is defined as a property of the view model, where the type is the app state. And you can see that actually state flow is defined as a computed property only with the getter and not with the setter. This is because data in MVI needs to be immutable. Okay, so we only have is read only basically, because all the modification to the state flow, to the app state, I mean app state, which is the value of the state flow, all the modification to the app state is made through this other component, which is the state manager. The state manager as a property has mutable state flow, which is the read-write version of state flow, which also takes the app state as its type. And then we also instantiate the data repository on the state manager. The two elements that we described earlier, we introduced earlier of the view model. So the events, which is actually what the UI layer calls directly. So we define events as the KMP view model class extension function. And then the state reducer, we define them as extension function of the state manager. Okay, so you might wonder why extension functions and not methods. And this is for organizational reasons. So the events and state reducer are defined as extension function, because extension functions allow us to split methods across different files. And this is very handy for our organization, because we can create inside the view model tree a folder with events and a folder with state reducers, where we organize all these event function and state reducer function by the name of the screen. So for the home screen, we have all the events organized in a file. For the profile screen, we have all the events organized in the same file, and same for the state reducer. This is very helpful for keeping the architecture, the file structure very clean and very easy also to manage across teams. Okay, let's talk more in detail about this state reducer. So the state reducer is essentially what creates a new state. Its role is to create a new state, and it has 3 inputs, which is able to combine and to use in order to provide a new state. So the inputs are the user event parameter, so inputs which come directly from the UI layer, then repository data, and the current state. And with these 3 inputs, the state reducer function is able then to create the new state. So let's show an example of an app. So let's say we have an app with a list of items. So in this case, we have cities as items. And this app could be either Android or iOS or web. No, doesn't make any difference. So if a user clicks on Berlin, what we do is calling an event function. And as we said before, the event functions are defined as extension functions of the view model. And we pass the parameter we click on, in this case is Berlin. So as you see, the events, which is called select city, it includes 2 functions, and these 2 functions are actually state reducers. So by clicking, we can expect that it's going to take time to retrieve the data that you want to show. So we might want to show a loading screen in the meantime, and then we are going to fetch the data and to show the other screen. So this is exactly what the state reducers do. So the state reducer that present the loading screen is what is doing is just flagging one property inside the app state that this loading screen is based on. So in the declarative, of course, we're talking about declarative UI. So in this declarative UI component, so we have like a component, let's say, which is the loading screen, which is, I mean, we're gonna have a navigation. Okay, let's make it simple. Okay, so this state reducer is just flagging a property, and based on the property, then the app is able to show a loading screen. Then what we want to do is to fetch the data asynchronously through this other state reducer, because we say the state reducers also have access to the data repository. See, this is what this other state reducer is doing. So it's, first of all, is fetching the data and is set into this detail property of the app state, and then is flagging back to false is loading property, so that we don't show the loading screen anymore. Okay, talking more specifically about the state reducer, about these 2 functions that we just seen. So the set loading function is simply, so here we are using this copy function, which is part of the Kotlin language. So the copy function is able to modify immutable data. Let's see like that, because actually what copy is doing is duplicating our object, and in the duplicated objects we just change one of the values. So what this set loading function is doing is simply duplicating by changing this loading property. And this other state reducer is doing something else, because it needs to fetch the data from the data repository. So based on the parameter that we have passed from the UI, is fetching the data from the data repository, and then is also changing the state by setting the new data and reverting the flag. So let's recap to what the state reducer is doing in the D-KMP architecture. So as we say, the state reducer is a state manager extension function, and is where with 3 inputs. One of the inputs is the user event parameters, which actually is the parameter of the function itself. In our case, this would be like the Berlin string that we've passed by clicking on this item. Then we have as an input the data repository, which is actually, as we said earlier, is defined as a property of the state manager. And then we have the current up state, which here what we are doing in state manager, we are creating a new computed property, which is the state, which is just for simplification, because the state, the up state, is the value of the mutable state flow. And for simplicity, we create a computed property with the getter and the setter, so that we are able to write very simply like this: state equal to state copy, and it's very easy to read as well. Okay. And then, with copy, we are able to create a new up state using this Kotlin's copy function. And in terms of data layer, the data layer is made up of a repository, which is connected to different data sources, which could be of any kind. So I'm just listing some of them. They could be web services, or GraphQL services, or runtime objects platform. So repository is providing data to the state reducers, and at the same time is also managing all the data caching mechanisms, so that the state reducer is just asking data to the repository, but then it's up to the repository to decide if this data is coming from the cache or is coming directly from the source. So there's lots of intelligence that is inside the data layer. And the fact that this data layer is multi-platform, it means that, and we can apply this to all these platforms, it means that we can also engineer all this data layer in a very advanced way to have a very cool and very smart caching mechanism, and with very advanced logic, because we don't need to care about duplicating what we are doing. We just write once and it's gonna run in all the platforms. And then I want to talk about GraphQL very quickly in one slide, saying that GraphQL is really great for KMP, and it really goes into the direction of KMP-rich clients, which is providing more freedom and more power to the client to retrieve the data from the server. I'm sure all of you know already what GraphQL is, so I don't have to say to repeat it. But with GraphQL, we are able to define from the client side which is the data that we want. So we kind of move a lot of code. So instead of creating web services which boringly, have to read write from each table in each database, so we are able not to write all this server-side code, because all the decisions that we are able to make all the decisions from the client side. So this is really fit perfectly with the whole concept of multi-platform and having rich client, because the server is going to be very thin and the client is going to make all the decision. And of course, this is going to work only for database data. So GraphQL makes sense mainly when you deal with database data. For other kind of external sources, you still need web services, of course. But many apps, they have to deal a lot with databases, and GraphQL is a great simplification. And in KMP, we have Apollo client, which is probably the most famous GraphQL client, which is now available. It's still experimental, but is already working, and it has an interesting feature like in-memory caching, and is even able to save permanently to SQLite. So it's very interesting. And this is the last slide where we summarize which are the libraries that we can use in KMP. So obviously in KMP, we are not able to use platform-specific libraries anymore. So we, instead of live data, in our D-KMP architecture with this upstate architecture that we're explaining during this presentation, we don't use live data. We just use Stateflow. And in terms of HTTP client, we don't use Retrofit or Alamo Fire. We use the KMP HTTP client, which is KTOR. Is the most famous one, which is developed by JetBrains. So in terms of serialization, we use Kotlin serialization, which is also a library developed by JetBrains. For structured data, we don't use Room or Core Data. We just use SQLite, which is a library which has been developed by Square. And for settings, we don't use share preferences or NS user defaults, but we use multi-platform settings, which is a wrapper actually to share preferences and user defaults. And we just a simple, it's doing everything under the hood. It's very, very, very powerful library. And in terms of concurrency, of course, we are going to use Kotlin coroutines, which actually is what even normal Android development should use nowadays. Okay, so this is the end of my presentation. If you want to know more about the D-KMP architecture, I suggest you to read this article, this Medium article that I published a few weeks ago, and you can Google it, or very easy to find. And I ask you to connect with me if you want to know more, or if you want to send me messages with Twitter. This is my Twitter handle. Okay, now I'm ready for questions, if you have any.
Can I jump in?
Sure, jump.
First of all, thank you, Daniele, for the presentation. It's really useful for me, at least. I have two questions.
Yes.
First one is related to MVI architecture.
Yeah.
Mm-hmm. So we have a global app state, right?
Yes, exactly.
So let's imagine we have 10 screens, and for each screen we should have a screen state, right?
Yes. Mm-hmm.
So what happens if the user navigates between the 10 screens? The app state is holding this whole data in the memory, or whenever the user closes the screen,
this could be, if you think that one of these state data is really huge, then you can actually set up some, kind of logic if you want to null some of these screens. But typically you would not really need. I mean, typically these state objects wouldn't be that big. So it makes sense to keep all of them, unless there is a real need for that. That from my experience. But there would be some cases where one of these objects is huge, and maybe you want to set it to null or to nullify somehow, to release the memory.
All right. And the second question is, for example, let's say we want to build an implicit service for inter-process communication, or to put simply, communicating with other apps that we build. Where we gonna put this service in the Kotlin multi-platform way?
So can you explain better? So you want to interact with another app. So can you tell me in detail?
So let's say we develop two apps. Let's say it's a banking app. One is for generating security token or whatever, and the other one is the client app. So we need to communicate with, we want to jump from this security token generator to our app for that, we need services to communicate between these apps. So how we gonna, where we gonna put this?
So this is this is a very advanced use case, I would say, which I haven't touched so far. But this is more to do with Kotlin Multiplatform than the architecture itself. So this is really a Kotlin Multiplatform question, more than architectural question. But I'm pretty sure that there are ways to do that very neatly. And you know that JetBrains, with Kotlin is really building a language which is really capable of doing everything. So I wouldn't be worried that you wouldn't be able to do that at all. But I'm not able to give you some specific answer for that.
Thank you very much.
Yeah, thanks also from me. I was really happy to see async tasks again. Thank you for those. We have one question in the chat from Giannis. How would you rate the maturity of Kotlin native for iOS? Do you have any experience, feedback from production apps?
I think it's okay. Most of the complaints that I see at the moment in the Kotlin Slack channel, it's mainly about debugging, because they would expect debugging to be more advanced. But these improvements are going to come, and these are actually in the timeline of Kotlin native by JetBrains. JetBrains now is publishing a plan of all the development is going to do in Kotlin, and one of these in the next months they're expecting to improve to make a lot of improvement to Kotlin native in terms of debugging. So this is coming very soon, so I would not be worried about that, but definitely it's not a blocker. So you can definitely start developing in KMP, and then maybe in the next months you get more and more tools which are going to make your work easier.
Nice, thanks. I don't see any questions from Slido or in the chat, so if you have a question, feel free to just unmute yourself.
Yeah, don't worry, just anyone that wants to make a question, just use your voice. We're just here in a friendly environment. We are just learning. Don't be afraid.
That said, there were more chat messages coming through. Do you think Jetpack Compose might also work on iOS someday? Maybe we should focus on Android-specific things on an Android talk, but
it's a very popular question, because people say, okay, if Flutter was able to run on iOS, why Jetpack Compose cannot? But I think Jetpack Compose is born with a different goal in mind. So Flutter, was definitely a multi-platform framework. Jetpack Compose is an Android framework. It was born as an Android framework. So it primarily is the new Android UI toolkit. And so we see that now Jetpack Compose is being ported to web and to desktop. But this development actually is not done by Google. It's done by JetBrains. Okay, so what I think is that if Jetpack Compose is going to go beyond Android, it's not going to go through Google, by Google, like Google has done with Flutter, but it might be done either by JetBrains or even by the community. So technically, yeah, of course, Jetpack Compose, Jetpack Compose, many people, they say is actually two things. One is the actual UI toolkit, and one is the compiler. Okay, so the compiler of Jetpack Compose is really multi-platform, so it can adapt in different environments. And this is what is used by the web, by the desktop. So it can easily, the Jetpack Compose compiler, be used also for iOS, to apply to iOS. But it's not going to be done, very likely. I mean, I might be wrong, but it looks like this is not Google's plan. It's not going to be done by Google, but it might be done by the community or by JetBrains, and it's not going to be probably very soon, because, yeah, that's what I say.
Thanks. Just going through the chat, do you know of any templates, projects that you could recommend for this architecture?
Template projects in terms of UI, you mean?
I feel this is more like a GitHub project where I see the whole architecture implemented.
Yeah, I mean, I meant to publish soon a repository with this architecture, but at the moment I still haven't had the chance. But hopefully in the next weeks I will be able to do that. But in my article, which is actually a 3-page article, in the last page, you see a lot of snippets, code snippets that they're really useful, that you can really set up easily yourself an architecture like that.
Nice. Thanks. So like, I think you would have the first one who gives the first star once you publish this GitHub repository. Then there's one other one who asks, you have stated 85% code sharing ratio as future. What is your current experience?
Yeah, that is my experience, exactly. So I've already worked on 2 apps using this architecture, and is really, you know, coming from Android development. I mean, I have experience with both Android and iOS in the past, but you know, and coming from both, from iOS and Android, you know, going to this approach, to this declarative UI approach with this global app state is amazing. You see how much simplification the whole things it can bring. And yeah, my experience is that one of 85% of shared code, with the UI code being really simple and stateless. And it's, I mean, I definitely see this is the future, you know. And one interesting thing I want to say is that it's very difficult to make bugs on the UI layer, because on these declarative UIs, the logic is so simple that, you know, you wouldn't even do bugs there. So once you have this 85% of business logic bug-free, then really it's almost like a joke to apply everything to a new declarative UI toolkit.
Yeah, interesting. Thank you. Just giving some more time for questions. Again, feel free to unmute. Maybe like another minute or so.
Sorry, can you hear me?
Yeah, can hear.
Yeah, sorry, I was fiddling with my audio setting. So this is kind of related to Android, but not really. It's more a general question. So imagine that somebody decides today to use the architecture that you described here. Many companies today have an Android team, an iOS team, and a backend team. So what would the team structure actually look like with this? So it's easy to imagine me as a solo developer doing everything and jumping left and right and doing this, and maybe have a colleague or two. But most of my experiences are with larger teams, so I cannot currently imagine how would that work. So can you maybe
something I also wrote in my article, and actually I'll bring up my article because I have actually a diagram that is, can you see the screen?
Yeah, we can see your screen.
Okay, yeah. So in the 3rd page of my article, there is something actually team organization, which is, I think, is going to cover your question very easily, very well. Yeah. So typically I can see 4 roles in a team. So there would be still a backend role, which could be, you know, nowadays many startups use Golang, but you could also use Kotlin JVM. Now there is this Ktor framework for Kotlin, which is many people now they are starting to use, which is making web services, writing web services quite easy. It's quite a smart framework. And yeah, so a backend engineer would use either, you know, Golang or Kotlin. Then you would have a data layer engineer, developer, that is the one that, if you see the architecture, yeah. So there would be like a data layer engineer that will deal with anything that has to do with data. So in this architecture, the data layer is dealing with all the different sources and is providing unformatted data to the view model. And then the other developer would be a view model developer, which is actually a developer which is able to get all the data from the data layer, but then is also dealing with formatting as well. And is also dealing with the structure of the data which is used by the UI. And then the 4th developer, it would be a UI developer. And the interesting thing, which I'm also writing in the article, is that declarative UIs, they're so easy and really, I mean, very easy to write if you compare it to the Android classical view-based system. So I would expect that UI developer in the future would be able to write both Compose and Swift UI. And actually, I think it would be a plus for a UI developer to know both UI toolkit, because they both influence each other, and eventually they're going to copy from each other the best things which come up. So a developer who keeps an eye on both UI toolkits would also be able to forecast what is the best for the future. So, and in terms of work, is not much work. I think a single person can easily manage both UI framework, UI toolkit. So yeah, to answer your question, so I would say 4 roles. One would be backend, another one would be data layer developer, another would be view model developer, and the other one would be declarative UI developer with both Compose and Swift UI. I hope I answer your question.
Yeah, so it would be much more vertical than it is right now, where we have segmented teams left and right. This would be literally just an MVI, but in a, not in architecture, but in a team structure, more like, makes sense. To me, it actually makes sense more to a new company or somebody that's going through a restructure than to an existing one, though. But I understand, and thank you.
Yeah, as I said also in my talk, so this D-KMP architecture makes sense mainly for greenfield projects. And if you want to, because you can use KMP in many different ways. You know, you can use KMP just for a module that you want to share across platform, and this is just another use case for KMP. So you can you can just write a new model, but then this D-KMP is about a new architecture based on MVI mainly for greenfield projects.
Sounds awesome. Thank you.
Yeah, thanks. Then maybe we finish with one last question. And in this case, I also wanted to go for something a bit more Android specific. How do you see like third-party libraries that are just written in Swift or Kotlin in this case built into this architecture? How can I integrate my native library in this one?
Yeah, with Kotlin Multiplatform, it's very easy to integrate platform-specific library. Maybe I'm also mentioning in the article. So they have this expect actual mechanism that if I click about, yeah, I'm just clicking, but I cannot see.
It's opened in a different tab. The next tab just.
Yes, exactly. So in Kotlin Multiplatform, we have this concept. Yeah, okay, let's not go into detail, but it's very easy, okay, to develop a new app. So you are able to wrap code which is written in Swift, which is connecting to the iOS framework, and then code which is written in Kotlin connecting to the Android framework, and you just get together these two variation with this mechanism which is expect actual. So in the platform you would define this function with the actual keyword, and you would be able to I don't know, without explaining it very badly, but anyway, so it's very easy. So you can write platform specific code in and wrap it. So this is actually what happened with for example Ktor client. Okay, so Ktor client is a client which is written by JetBrains, is an HTTP client, and is actually wrapping the Android HTTP, I think it's HTTP URL connection, and then is wrapping NS URL session from iOS. So most of this library, I mean, not all, so some library are like pure Kotlin. For example, Kotlin serialization, I think, is pure Kotlin, I believe. But libraries like multi-platform settings, Ktor client, they are wrapping code which has been written originally in the platform. So it's really easy to reuse any platform-specific code. Yeah, in Kotlin multi-platform.
Nice. Yeah, thanks. I hope this answers most of the questions. But like Daniele, like you said, you are also available on Twitter and whatnot. If there are more questions happening, obviously feel free to reach out. What I would now do and ask us to do is that we stop the recording, Hassan. I'll do the same. And then we'll say thank you.